This question says a bullet travelling at a speed of 110 meters per second penetrates a tree trunk to a depth of 65 millimeters. Calculate the duration of the impact of the deceleration of the bullet. Once again, it's good to start by writing down what we know. In this case, the initial speed is 110 meters per second, and the depth, that's the displacement of the bullet during the impact, 65 millimeters. We're going to be careful with the unit here because we want this normally in meters. So 65.0, and then the prefix milli means times 10 to the minus 3. Rather than trying to write 0.00 and getting into a mess with how many zeros to write, we just transfer the prefix straight into its power of 10. The hidden sort of piece of information in this calculation is that the bullet comes to a stop. So if we know that it's got some final displacement, then it must have stopped. So the final velocity is equal to 0 meters per second. Part 1 asks us for the duration of the impact. That's the time t. So we want the equation that links t, u, s, and v. That's our s is u plus v over 2 times t. Rearranging this for t, we get 2s over u plus v. So our line of calculation is going to say 2 times 65.0 times 10 to the minus 3 divided by u, which is 110, plus v, which is equal to 0. This gives us the time of impact of the bullet of 1.18 times 10 to the minus 3 seconds. Part 2 asks us for the deceleration of the bullet. So here we're going to try and find the acceleration first. I have to be a bit careful with signs here. So we should expect that v being lower than u is going to give us an acceleration value that is negative, but at the end we're going to convert it into a deceleration value. A negative acceleration is a positive deceleration. So we want the equation that links u, s, v, and a. That is v squared is equal to u squared plus 2as. Rearranging for a gives us v squared minus u squared over 2s. So putting the numbers in, this is 0 squared minus 110 squared divided by 2 times 65 times 10 to the minus 3, which gives us our acceleration, again, this time rounded to 3 significant figures, of 93100, so 93,100 meters per second squared.